Hey everyone, my name is Elaine and in this video I'm going to talk about radioactivity. I divide this topic in two parts and this is part 1. So let's start by remembering the basic definition of atoms. Atoms are the basic units of matter in the defining structure of elements. The word atom comes from the Greek word indivisible because in the beginning they thought that atoms could not be divided. But we have to keep in mind that all matter is composed of atoms. Atoms have outer shells and the nucleus. In the outer shells, we have the electrons, which are negatively charged. In the nucleus, we have the protons, which are positively charged, and the neutrons have no charge. As far as mass, the mass of a proton and a neutron when compared to an electron is way bigger, about 1800 times the size of the mass of an electron. So this is why when we talk about atomic mass, mass number, we are referring to the mass inside the nucleus, the elements inside the nucleus, protons plus neutrons. So this is a way of representing an atom. We call atomic notation, nuclear notation, where X is the element symbol. A is the mass number, and like I said, the mass of atom is confined in the nucleus. So we are talking about protons plus neutrons. Z is the atomic number, the number of protons. It is the atomic number that defines the element. So let's take a look in this example. We have iridium-192 that we use in radiation therapy. So in this kind of notation, we only show the mass number. 192 refers to the mass number of iridium. So if we want to represent the atomic number as well, we need to write in this way. 77, it is the atomic number. So what is radioactivity? Radioactivity is the physical phenomenon of certain elements of emitting energy in the form of radiation. This energy comes from the decay of unstable nucleus. So let's take a look in this plot here. The x-axis shows the proton number, the y-axis the number of neutrons. And let's take a close look on this red curve here. Up to 20 here, 20 protons in the nucleus, we're going to have about 20 neutrons in the nucleus. That means the ratio neutron to proton, it is 1. After 20 protons in the nucleus, as the number keeps increasing, the number of neutrons increases exponentially to be able to compensate for that energy of the protons there. So there are certain combinations of number of neutrons and protons in the nucleus that will cause the atom to be stable or not, the nucleus to be stable or not. So radioactivity, it is a nuclear phenomenon. Unstable nucleus has excess of energy. If there is a combination inside the nucleus where the ratio of neutrons to protons do not keep that atom stable, therefore there will be an excess of energy there. This excess of energy needs to be released in the form of ionizing radiation. Atoms with unstable nucleus are called radionuclides. So radioactivity was first discovered by Becquerel in 1896. So let's take a look in this illustration here. This is just to help us to visualize what I had said so far. So when we talk about radioactivity, we are talking about radioactive decay of an atom. Here it represents the nucleus of an atom, protons and neutrons, If the combination here of the number of protons and neutrons is unstable, creates an unstable nucleus, there is an excess of energy which needs to be released out of the nucleus in the form of electromagnetic wave, gamma rays, or particles, alpha particle or beta particles. Alpha and beta particles have energy and mass. Alpha particles are relatively heavy, are positively charged. They are formed by 2 protons and 2 neutrons, each alpha particle. Are high energy particles that cannot penetrate most matters. Beta particles, compared to alpha particles, are small, fast-moving particles. 2 types of beta particles. We have beta minus and beta plus. Beta minus is an electron emitted after the transformation of a neutron into a proton inside the nucleus. Beta plus, it is a positron emitted after the transformation of a proton into a neutron inside the nucleus. So beta plus, or we call positron, is a positive electron. Gamma rays are packets of electromagnetic energy. We also call photon, have the smallest wavelengths and the most energy of any wave in the electromagnetic spectrum. So this illustration here shows the relative abilities of 3 different types of ionizing radiation to penetrate solid matter. We can see that alpha particles are stopped by a sheet of paper. Beta particles are stopped by aluminum plate, and gamma rays are stopped by lead or concrete. So we talk about photons when we mention gamma rays. We said gamma rays are also photons. So let's work in this definition a little bit. A photon is a particle of light, defined as a discrete bundle of electromagnetic energy. They behave like a particle and a wave simultaneously. They move at constant velocity in empty space, at the speed of light in empty space. They have 0 mass and rest energy, so photons only exist as moving particles. They carry energy and momentum, which are also related to the frequency and wavelength. They can be destroyed when radiation is absorbed. They can be created when radiation is emitted. They can have particle-like interactions, for example, collisions with electrons and other particles. So examples, we already mentioned gamma rays. We also have X-rays. Both are photons. Both have the same properties. So what's the difference between them? It is their origin. Gamma rays originate in the nucleus and X-rays in the electron shells. So part 1 ends here, and in the next video, in part 2, I'm going to talk about half-life, the activity of a source, their definitions. We are going to do a math problem using the activity equation. And so see you in the next video. Thanks for watching.